In the summer of 1944, an RAF pilot chasing a flying bomb had only seconds to judge how close was close enough. Behind the gun sight was the Hawker Tempest, one of the fastest piston fighters Britain had ever put into service. It had the basic ingredients of a late-war interceptor, including remarkably low-altitude speed, a steady gun platform, and 4 20mm Hispano cannons, with enough firepower to rip apart a small delivery truck in one go. If the Luftwaffe had still been appearing in large numbers, those qualities could have made it famous for chasing German fighters over Europe. Instead, its first great enemy had no pilot. On June 13, 1944, one of the first V-1 flying bombs to reach Britain struck London, hitting Grove Road in Bow before dawn. The blast destroyed a railway bridge and nearby homes, took the lives of 6 people, injured 30, and left around 200 homeless. The V-1 carried its explosive load in the nose. It was about 25 feet long, with a wingspan of roughly 16 feet, about the length of a small bus. Once it left the launcher, there was no crew to force away, no pilot to frighten, and no return journey to prevent. With a range of about 150 miles, it could be fired from occupied Europe and sent across the Channel without putting a German crew in danger. It crossed under pulse jet power, flying low and fast until its preset mechanism cut the flight short. Then it dropped. That made it different from every airborne threat Britain had fought before. Instead, the V-1 gave fighter command a target that was small, hard to see, low-flying, and moving at roughly 350 miles per hour, in some conditions closer to 400. A pilot had only a short window to find it, catch it, line up the gun sight, and fire before it reached the city. At Royal Air Force Newchurch, the newly arrived Tempest squadrons had been prepared for fighter sweeps over France, for the kind of air combat that made aircraft famous. Yet almost as soon as the Tempest entered the fight, it was pulled back into Britain's air defense. Beside a Spitfire, the Tempest looked like it should need more runway and more effort to get into the air. Its long nose sat heavy out front. The deep chin radiator gave it a blunt face. The bubble canopy rose high over the fuselage, and the wide wings made the whole aircraft look broad and heavy on the ground. But it was fast enough to catch a V-1. Tempest squadrons guarded the approach routes, waiting for radar to point them toward the next flying bomb. When the word diver came through, a flying bomb was already somewhere ahead, crossing the coast. The patrol turned toward the track, searching for a dark speck, a pulse jet flame, anything that marked the target before the distance ran out. With external tanks attached, Tempest could remain on patrol for hours. Some even stood off the south coast for around 4.5 hours, waiting for the next warning. The attack had to be set up in seconds. A Tempest pilot might dive to build speed, then cut across the bomb's path to gain a firing angle. If he approached from behind, the closing distance could disappear quickly. If he came in from the side, the shot required lead and timing. Either way, the aircraft had to be held steady, long enough for the gun sight to settle. At night, the pulse jet's flame could make the V-1 easier to spot, though catching it was still another matter. In daylight, the V-1 could be little more than a small dark shape moving through haze. Some fighters could reach a V-1 only under the right conditions, but reaching it was not the same as stopping it. At low altitude and high speed, the pilot still had to keep the nose steady and make small corrections before the firing window closed. Thanks to its thinner wing, the Tempest suffered less drag and vibration at high speed. Above about 250 miles per hour, the Tempest spring-tab ailerons reduced the force needed on the controls. That allowed the pilot to make small corrections while closing on a target, moving at roughly 350 miles per hour. On June 16, 1944, only days after the first V-1s reached Britain, No. 150 Wing was sent into one of its early diver patrols. By the end of the day, the wing was credited with 13 flying bombs. By mid-August, Tempest claims had climbed past 600. And yet, those numbers came from attacks that were carried out closer and closer to the bomb itself. The Tempest had the speed to reach the V1, but bringing it down often meant taking a greater risk, closing the range. The Tempest's main advantage against the bombs sat inside its wings. 4 Hispano cannons firing explosive shells that put both aircraft in danger. Together, the cannon carried 800 rounds, about 200 per gun, enough for repeated short bursts during patrols. The guns were often harmonized around 200 yards, meaning the streams of fire from the wings met at that distance ahead of the aircraft. A burst could damage the flying bomb enough to send it down, wrecking the pulse jet, damaging the control gear, or setting off the warhead. Since the target was also a warhead in flight, if the pilot opened fire from too far away, the shells might miss or fail to do enough damage before the V1 continued on. If he closed too far, a successful hit could put him inside the blast. Early attacks were sometimes made from around 400 yards, but pilots often ended up closing far nearer, toward 150 to 200 yards, to make the shot count. That danger forced some pilots to try stranger methods to dispose of the bombs. For example, whenever a clean shot was not there, ammunition was running low, or firing risked detonating the warhead too close, some pilots tried to bring their fighter alongside the bomb itself. The idea was not to ram it, but to slide a wing near the V1's wing, sometimes just beneath it, and disturb the airflow enough to upset the bomb's autopilot. When it worked, the V1 rolled away, lost control, and crashed before reaching London. A misjudged approach could damage the fighter. A sudden movement from the V1 could put the aircraft in contact with the bomb, and if the warhead detonated nearby, the fighter could be torn apart by the blast. Still, at least 16 flying bombs are known to have been brought down this way. However, the method became even less attractive once warning spread that some bombs might be rigged to explode if disturbed. As the campaign developed, Britain turned the chase into a coordinated defensive system. Once controllers understood the flying bombs' routes and behavior, radar stations tracked them across the channel, while fighter controllers directed patrols toward their expected paths. Meanwhile, anti-aircraft guns were gathered into heavy belts near the coast as balloon barrages covered the last approaches to London. By the time the campaign matured, Tempest squadrons had built the strongest fighter record against the V1. Tempest are credited with bringing down 638 flying bombs out of 1,846 destroyed by aircraft, or about 34% of the total. The Tempest became one of the strongest fighter elements in the defense, but its victories were now part of a larger machine that was already tightening the net around the V1. At the same time, Allied armies were moving through France and Belgium toward the launch sites, which were being bombed, captured, or pushed out of range. However, the Tempest had never been built for a war like this. Its success against the bombs came from years of work on a different problem, one aimed at taking a powerful but troubled fighter and making it fast, stable, and trusted at high speed. The Tempest began as Hawker's attempt to redeem the Typhoon, its earlier design, a powerful RAF fighter built as a high-speed interceptor, but forced into service with serious flaws. Hawker, the British aircraft company, led by designer Sidney Cam, had created both machines, and by 1941, it was trying to turn the Typhoon's raw power into something pilots could actually use. The main issue was that the Typhoon did not inspire trust. Reports of rear fuselage and tail failures meant the Luftwaffe was not the only danger Typhoon pilots faced in 1942 and 43. At high speed, they also had to trust that the aircraft behind the cockpit would stay together. Even when the Typhoon held together, its shape worked against it. The wing was too thick for the high-speed interceptor role it had been designed to fill. At low speeds, that wing gave the aircraft room for fuel and weapons. Near the top of its speed range, it created heavy drag, vibration, and and poor handling. The harder the Typhoon was pushed, the more its own wing held it back. Around 25 Typhoons were lost to tail failures, with 23 pilots unable to survive those incidents. In August 1942, Hawker test pilot Ken Seth Smith was lost when a Typhoon broke up after elevator flutter caused the rear fuselage to fail. To save the Typhoon, Hawker's wartime design office at Claremont put a team of 45 draftsmen to work, turning the Typhoon II proposal into manufacturing drawings. A stronger engine would not solve the problem. The Typhoon already had an enormous output. What it needed was cleaner speed and steadier behavior under load. A pilot had to be able to dive, chase, aim, and pull out without wondering if the aircraft would fight him or fail around him. The most important change was to the wing. The new design adopted a much thinner profile to reduce drag and improve high-speed performance. On the Typhoon, the wing was about 19.5% thick at the root. The new model dropped to about 14.5%, tapering to 10% at the tip. The thickest part of the wing was also moved farther back, from about 30% of the chord on the Typhoon to 37.5% on the Tempest. This gave the aircraft a cleaner shape at speed. At first, the project was still tied to the Typhoon name, known originally as the Typhoon II. But the changes went too far for that name to hold, so by the time the redesign was ready, it had become a different fighter altogether. And so, it became the Tempest. With the Tempest name now in place, and the war moving faster than the design office could, Hawker worked several versions at once. Some promised new engines, others promised cleaner noses and more radical layouts. The possibilities widened, but only one version would reach combat first. The Mark I was meant to use the Sabre 4 with wing radiators, and no Typhoon-style chin radiator, but that engine and cooling layout caused delays. The Mark II used the Bristol Centaurus radial. Other prototypes were planned around Rolls-Royce Griffin engines. The Tempest Mark V, the version that reached combat first, used the available Sabre 2 engine family and kept the familiar Typhoon-style chin radiator. It also carried the new wing and improved airframe that made the Tempest different. The Mark V prototype first flew on September 2, 1942, and the first production aircraft flew on June 21, 1943. Instead of ordinary valves opening and closing at the top of each cylinder, the Sabre used moving sleeves around the pistons to move air through the engine. That helped the engine produce about 2,420 horsepower on emergency boost for 5 minutes at sea level, driving a 14-foot, four-bladed de Havilland hydromatic propeller. The aircraft held together better at speed, answered more cleanly, and gave pilots more confidence when diving or closing on a target. Its thinner wing reduced drag and vibration at high speed. Its enlarged tail helped keep the aircraft stable. The fuselage was stretched as well. Part of that extra length came from a new fuel tank placed ahead of the cockpit, because the thinner wing had less room for fuel. But the longer nose created its own problem. With more aircraft ahead of the pilot, the Tempest needed more help staying steady from side to side. Hawker answered with a larger fin and tail surfaces, giving the aircraft more authority at speed. The cockpit view improved as the design evolved, helped by the bubble canopy. The windscreen and side windows benefited from the study of captured Focke-Wulf FW-190s, with the framing arranged to reduce blind spots. The center windscreen panel was bullet-resistant glass, with an outer layer about 1.5 inches thick and an inner layer about a quarter-inch thick. As an interceptor, the Tempest V had a gross weight of around 11,400 pounds and could reach about 435 miles per hour at 17,000 feet, climb at roughly 4,700 feet per minute, and reach 20,000 feet in about 6 minutes at combat power. Below about 20,000 feet, the Tempest compared strongly with better-known fighters such as the Mustang III, Spitfire 14, Bf-109G, and FW-190A. At higher altitudes, other fighters could do better, but the Tempest's best work came low down, where trains and vehicles moved, and where German fighters tried to escape in a dive. In early official trials, pilots found the Tempest more pleasant and controllable than the Typhoon, with no major handling faults reported. That was the only thing the RAF needed to hear to know the aircraft had finally become what Hawker had been trying to build. Now, their only obstacle was time. The Air Ministry placed an order for 400 aircraft before the Tempest 4 prototype had even flown. Britain wanted the corrected Typhoon line in service as soon as possible, but ordering the Tempest was one thing. Getting it to the front before the war moved past it was another. Number 486 Squadron, RNZAF, began receiving Tempests in January 1944. Number 3 Squadron followed at the end of February, and Number 56 Squadron joined soon after, forming the core of Number 150 Wing under Roland Beaumont. As a result, the Tempest reached the front late. By the time of D-Day, the Tempest was only just entering frontline combat, and by the time its squadrons were ready around Normandy, the Luftwaffe was no longer appearing often enough to give the Tempest a long public trial over the beaches. Over the invasion area, Allied air power was already overwhelming them. Just as the aircraft was ready to fight, the enemy was already being pushed out of the sky. It wasn't until June 8, 1944, 2 days after D-Day, that they clashed with the Germans for the first time. 9 Tempests from Number 3 Squadron encountered a group of Bf-109s over northern France. They attacked and shot down 3. Despite being one of the Royal Air Force's strongest low to medium altitude fighters, the Tempest 5 did not yet carry the newer gyro gun sight fitted to some Spitfires and Mustangs. Its pilots were still using older reflector sights during high-speed attacks against fighters and flying bombs, which made the early record stand out even more. However, the momentum was cut short as the V-1 emergency pulled them away from France and back into Britain, redirecting them from offensive sweeps to the pursuit of pilotless bombs. Normandy should have been the Tempest's entry into the classic fighter war. Instead, it received only a brief glimpse of that war, before being pulled into a different one. After the flying bomb campaign began to fade, the Tempest went back across the Channel, looking for the kind of combat its designers had expected. The squadrons moved forward to the continent, including Vogel in the Netherlands, a forward airfield that had been bombed into a wreck before the Germans left, with hundreds of craters, ruined buildings, and only the runway and repaired perimeter track left to work from. From there, Tempest patrols crossed the front and searched for rail lines, road convoys, canal traffic, parked aircraft, and communication towers. A typical armed reconnaissance patrol went out in 2 sections, usually totaling 8 aircraft. They crossed the front at 7,000 to 8,000 feet. One section then dropped to 4,000 feet or lower, scanning roads, sidings, canals, and airfields for movement. The other section stayed higher and down sun, watching for fighters and flak. When the low section had made its pass, the roles could switch so that the hunt could continue until the cannon ammunition ran out. Many worthwhile targets lay around 250 miles from base, so the aircraft often carried 2 45-gallon drop tanks. Keeping the tanks at a cost of only about 5 to 10 miles per hour was little compared with the ability to range deeper behind German lines and still return. In practice, pilots often wanted to jettison the tanks before going into action. If a drop tank caught fire under the wing, a damaged aircraft became much harder to save. Once a target appeared, the search collapsed into a brief cannon pass. A train in a cutting, trucks on a road, barges in a canal, aircraft parked on a field. The Tempest came down hard, made a short cannon pass, and climbed away before the ground crews or gunners could fully react. It didn't always need to destroy a train outright. A burst into the engine, wheels, fuel, or controls could be enough to block the line, delay supplies, and slow orders, making German daylight movement more costly. One Tempest pilot later remembered attacking a train after the crew jumped out and rolled down the embankment. The engine kept steaming forward without them, disappearing down the line. The pilot never knew where it finally stopped, but the railway had been disrupted all the same. Operation Market Garden, launched in September 1944, was the Allied attempt to grab key bridges across the Netherlands and force a route into Germany. Troops were dropped around Arnhem, Nijmegen, and Grave, but once on the ground, they relied heavily on aircraft for transport, supplies, and support. German flak around the bridges and drop zones threatened transports, fighters, and any aircraft trying to reach them from the air. So Tempests were sent after those guns. They attacked flak positions, trying to reduce the fire, threatening the aircraft above and the troops below. As a result, 3 Tempests were lost under fire. This is how they learned that the more the Tempest worked at low level, the more it entered the range of every gun guarding the targets. German fighters were still dangerous, but flak waited around rail yards, bridges, roads, airfields, and troop positions. The Tempest could outrun many aircraft. It could not outrun a shell already fired into its path. One pilot later remembered that a 10-week stretch reduced the squadron by roughly 20 to 25 pilots through losses, wounds, transfers, and removals from the line. The aircraft finally found a role it could do better than most, and the reward was a battlefield filled with ground fire. But the Tempest had not run out of aircraft to fight. After months of chasing bombs, trains, and flak positions, German fighters began appearing in front of its guns again. Bf-109s, FW-190s, and the newer FW-190D9 were still flying over the Low Countries and Western Germany. Even late in 1944, these were still dangerous fighters, often flown by German pilots who knew how to use them. But the lower the fight went, the more it suited the Tempest. At that altitude, decisions had to be made quickly, and one bad move could decide the whole engagement. Against Bf-109s and FW-190s, the Tempest speed put pressure on every escape choice. Staying level risked being caught. Diving did not always break contact. Turning hard created only a brief opening, and the Tempest pilot had to use that moment to bring 4 cannons onto the target before it vanished. During the Ardennes offensive, German ground forces attacked in the west, and the Luftwaffe returned in greater strength over the battlefield. The Germans needed fighters to cover the offensive, contest Allied fighter bombers, and protect the roads and rail lines feeding the attack. The Tempest met German aircraft in the air, using speed, dives, and cannon fire to settle the fight quickly. During this period, Tempest claimed 38 enemy aircraft. And still, at the same time, these same Tempests were also being sent to attack the machinery behind the front. Even if it proved itself as a fighter, the two jobs kept overlapping. After months of hard use, Tempest units needed an overhaul, engine servicing, and fresh pilot training. When they returned in December, Allied armies were pushing toward Germany, and the German army depended heavily on rail lines to move troops, fuel, and ammunition. The Tempest's new assignment was to break the North German rail network and destroy any high-performance Luftwaffe aircraft that came up to defend it. In December 1944, Tempest reportedly destroyed 52 German fighters, 89 trains, and large numbers of military vehicles, while losing 20 Tempests. Then, on January 1, 1945, the Luftwaffe struck back with Operation Bodenplatte. German fighters came in low against Allied airfields, aiming to destroy aircraft before they ever got airborne. The raid caused serious losses, around 144 aircraft destroyed on the ground, 62 damaged, and 70 more lost in aerial combat. The cost to the Luftwaffe was harder to absorb for the waning Reich. Germany lost about 304 aircraft, and 214 aircrew were either captured or did not return. While the raid proved the Luftwaffe could still hit Allied air power, it also burned through the trained airmen it desperately needed for the war's final months. After Bodenplatte, the remaining fight shifted even more toward the low and medium altitudes over the front, the exact band where the Tempest was strongest. For the 2nd Tactical Air Force, the Tempest became more valuable, as it could hunt German fighters still willing to appear then turn its cannon on trains, vehicles, and airfields before returning to base. After the raid, 122 Wing carried much of the 2nd Tactical Air Force's low to medium altitude fighter work. By this stage, Tempest units are credited with an estimated 239 confirmed air-to-air victories, plus 9 probables, against 31 losses and probable losses in air combat. It was roughly an 8-to-1 ratio, excluding V1s. Then the war changed the rules again. The piston fighter itself was being pushed toward obsolescence. The Tempest's next enemy was a different generation of aircraft altogether. Germany was putting machines into the air that no piston fighter could treat as normal opponents. The Me-262 jet fighter, the Arado Ar-234 jet bomber, the Henkel HE-162, and rare high-speed machines like the Dornier 335. Once any of them had speed, altitude, and room to escape, the Tempest could not simply run them down. By 1945, these aircraft were pushing the war beyond the limits of piston power, even for one of the fastest Allied fighters at low altitude. Even so, Me-262 pilot Hubert Long reportedly considered the Tempest the jet's most dangerous opponent because it was fast at low altitude, maneuverable, and heavily armed. Despite this, Tempest pilots adapted by hunting jets near their airfields, where the faster aircraft were slower, lower, and easier to catch. This became the logic of the rat scramble. Tempest pilots waited on immediate alert. When reports came in that Me-262s were active, they took off and raced toward the jet bases. One of the main targets was Rheinhofstein, known to be home to Me-262s and AR-234s. The Tempest pilots tried to catch the jets when the German aircraft were low, committed to landing, short on fuel, or flying with their landing gear down. On February 11, 1945, near Hanover, David Fairbanks chased a jet through the clouds and caught it as it prepared to land. Fairbanks was an American, serving in the Royal Canadian Air Force, and the top-scoring Tempest ace, credited with 11 or 12 German aircraft destroyed, plus 1 shared. The aircraft he hit was claimed as an Me-262, though later evidence suggests it was probably an Arado Ar-234. If that's correct, it may have been one of the first AR-234s shot down by an Allied aircraft. Later that month, Fairbanks was shot down and captured. On April 19, 1945, Geoffrey Walkington shot down a Henkel HE-162, one of Germany's newest jet fighters, shortly after the type had entered service with the first group of Jagdgeschwader 1. The jet, flown by Feldwebel Gunther Kirchner, was shot as it was committing to a landing near the airfield. It went down, with Kirchner still inside. In response, the Germans began protecting the jet bases. Flak guns covered the approaches, the runways, and the routes Tempests were likely to use. Around Rheinhofstein, German defenses reportedly included more than 150 Flak-Vierling quadruple 20mm anti-aircraft mounts covering the approaches. To catch a jet at its weakest point, the Tempest now had to fly into some of the most dangerous airspace in Germany. Near Rheinhofstein, 7 Tempests were lost in 1 week. After that, the rat scramble was stopped, and for a few days in March 1945, the order was, quote, no ground attacks. After the war, the Royal Air Force selected the Tempest as its standard fighter, but only while it waited for the next generation of aircraft, such as the de Havilland Hornet, Gloucester Meteor, and Vampire. Several squadrons used the Tempest as their final piston-engine fighter before converting to jets. Once the new generation arrived, the Tempest's moment had already passed. It had arrived as one of the last great answers to the piston fighter war. And still, every role that proved the Tempest's strength also showed how quickly the war was moving beyond it. The same aircraft that helped mark the end of the piston fighter era reached its peak just as jets began taking the future away. In the end, it was overshadowed because it succeeded at the very end of the world it had been built for.